So hello, it's Pierre speaking again, and this is part 2, the draft version of part 2 of this Peripheral server training. Just for a quick recap, so where we finished is in the part 1. So in the part 1 we essentially prepared some skeleton of this Peripheral OPC-UA server. The green one, which is completing this, is the aim of our exercise here. And so we added a method, OPC-UA method, which when invoked, it can at this stage just run the custom code. So that was just a silly printout, like here called configure. But of course, it should be more advanced because of course the configure will run some actual SCA transactions that will drive the peripheral chips to this or that flavor. And where we're standing at this moment is that we don't have this violet arrow here, whatever color this is, right? Because a recap here would be that the orange box is an OPC-UA server, right? This is the OPC-UA server for the SCA, the same one I'm running here in my second tab, right? So since this is an OPC-UA server, then we need an OPC-UA client that would connect to the server, such that, for instance, if we look at the address space of the primary SCA server, we see here like register 4, register 5, so it could connect as a client and invoke some sort of write-read method call, stuff like this. So of course you could like write an OPC-UA client from scratch, but this is not what we're suggesting, because this orange box, the SCA OPC-UA server, has been constructed using Quasar framework as well, and that means that you can use Quasar to generate a client in C++ which matches the information model of the server. And the general name of clients generated in this way, this is called UAO. It's not related. It's a DCS product. Let's call it this way. It's not defined by OPC-UA Foundation or something like this. It's a DCS product, but it's fully compliant with OPC-UA. And UAO stands for UA objects, so objects for OPC-UA. And why objects? Because we adopt kind of something like object request broker approach to that. And I think when I show you an example for UAO client, it will become more obvious. So the UAO clients for SCA. We as a group who makes this OPC-UA server, we actually regenerate each time we change something relevant, and we publish this for you, which means the client you can essentially take from the Git repo. So when you go to gitlab/ch atlas DCS OPC-UA servers, among many different servers, you will find UAO client for OPC-UA SCA, right? So you look at this thing. Wait, it's loading. Right. So it's a normal C++ project, but when you look, for example, in include, what you will see here is per every class that is defined in the SCA OPC-UA server, you actually see a header file, and inside there's a class. So why I'm saying per every class? Because well, I can show you. If I go to my SCA OPC-UA server project, I do the same thing that we did with generate diagram. If I do the same thing like we did with our LTDB server, so I'm generating this diagram. Now I'm gonna open this. So this is the diagram for the SCA OPC-UA server, and you see classes like SCA, analog input, SPI, and stuff like this. So if you, for instance, pick, I don't know, like I2C master, yeah, which is here, then you look into UAO client and you also see I2C master, right? And it's here. And if you look inside this file, what you see is that apart from constructor, but then you see that per each OPC-UA variable, so going back to the diagram, so you see that, look, you see that I2C master, you have a variable called diagnostics. And then what you find in this code is a method called read diagnostics. You know, it does what it says. It just does a read transaction to the variable called diagnostics, right? So it's kind of automatically generated the name mapping for this. So if this variable was writable, which is not, but if it was writable, then you would have also a method called write diagnostics, right? If you find somewhere, if you find a method, for example, you have a method called ping or reset, then you're gonna find a method called call reset, call ping, etc., etc. I think you clearly see the analogy. So what this class I2C master does, it's any other from this UAO client. So any that you can see here, they essentially are essentially proxy objects. So they behave like you had a real I2C master sitting on the SCA, but when you actually call this read diagnostics, it wraps OPC-UA code, which can connect remotely and call something. That's what we're trying to do here. Okay, so the takeaway message is that we have and publish an OPC-UA client which is in C++, which is strictly mapped to the SCA. It can be compiled using the same open source software, and we can easily integrate this into our peripheral server. So therefore, the overall cost of establishing this connection from peripheral server to the orange box, to the OPC-UA SCA server, should be rather low, and this we'll try to study in our example. Right, so by the way, the same diagram for your reference for the SCA OPC-UA server, you will find in the deliverables that we provide to you. So whenever you download it from this GitLab continuous integration, you're going to find this diagram inside for your reference. Alrighty, so where shall we go now? I think we should start deploying UAO client. So the thing which we can find here. So we should start putting this inside or make it available to our LTDB server, or peripheral server, just speaking generally. So what we can do here is there are few possibilities. I think a fairly clear one is using Git submodules, and well, let's give it a try. We'll see if we can have a good time with that. So I just copied the clone link for UAO client for OPC-UA SCA from the GitLab at CERN, right? And then what I'm doing in my peripheral server, so what I'm doing here is I'm saying the following. So git submodule add this. Yeah, so here I should log in myself. Hope it works. Yes, apparently. And so let's see what the situation changed. So we have Eclipse project, and now we have, you see, this UAO client for OPC-UA SCA, and all the files are here. All the files are here, and okay. So information for me, I've gotten the CMake list here. Right, so here I made one correction behind your back, frankly. I had one missing commit. So when you do this after me, you're gonna see this already. Anyway, after adding the submodule, here's the situation which you should see. So CMake list, include sources, etc., etc. Now, how do you actually integrate this this module to be built along Quasar server? You go into the project settings from the from this directory, and then you have something like custom server modules. And here, what you do is you essentially give the name of this module, which would be UAO client for OPC-UA SCA. I think this is probably correct. And then let's see what happens when I try to build this. Okay, so it looks like the server is built, I suppose including, so you can see the UAO client has been compiled. So essentially it's now part of, it's now linked with the executable, which means that we can start profiting from this, right? So if we get back to this picture, if we get back to this picture, or maybe even better, we get back to, oh, and unluckily I think I closed this. That was what, OPC-UA 11 training for cascading. I think this one, right? 1191, right? So remember where we've been. That we noticed that we have an access to those OPC-UA variables, which are, you know, MTRX control, which is I think I2C or something. And then we added a method. You remember this probably. We added a method, you know, configure in LTDB MTRX. So what we want to do now is actually we want to put this code, this statements like write 05, write 19 into these registers. And the question is how do we do this? So here's the thing. So first of all, we go to this UAO client for OPC-UA SCA, right? How do we find which class is that actually? Well, this you know from your hardware description, but in case you don't know, what you can do is, you know, you go to, for example, register 4, right? And then if you in UA Expert you open references, then essentially you know that by looking for has type definition, you know that register 4 is I2C slave. Okay. So it means that if you want to write to register 4, you should, you know, create an object I2C slave, which is, you know, in this header file from UAO client for OPC-UA SCA, right? So what I'm gonna do here is I'm gonna simply include this header file, which happens to be I2C slave.h. Right, nice. And and then what I need to do is well, is the following. So this is all in the namespace UAO. What's the case here? I think like this one, right? I2C slave. Yes. So I call it, let's say, register 4. Right. Now, why Eclipse is not showing this to me? This I don't know. But what I can tell you is, if we look into I2C slave, when you want to construct this, it expects UA session. UA session essentially corresponds to a client connection and something called object ID, right? And now, how do you find this? What's the UA session? Well, you need to actually create the connection. Yeah. So how do you create the connection here? You have another header file called client session factory, which we will include in here as well. Hopla. Client factory.h. Yes. And now, so I want to have this session, UA session. Okay. session, I'm gonna do UAO client session. It's probably not in this namespace. Probably I have to fix it for another iteration. Right, connect is what you want to call. So here, what's your what you put here into connect? This is your OPC-UA endpoint of the primary server, right? So the server which is running here, okay? So for a quick, just to keep it concise, keep it obvious, I just, I will just copy paste this endpoint URL. It's the same thing you put into UA Expert to connect initially, to add the service. It's essentially the same thing. I'm gonna do it this way. It's a bit not nice. I don't want to have this in my final source code, but it's just for training. I will improve it later. So I have this session. If not session, then probably I'm gonna kind of return something like OPC-UA bad communication or something. Okay. And so since I have this session, right, then I can use this session to create this I2C slave, and then it expects something called node ID. And what node ID is the following. You can read this from UA Expert. So what you do here is you click on this register 4, and then you see attributes, and then you see something that it's identifier. It's a string identifier. Not going to the details. In Quasar, absolutely majority of identifiers are string type. So this you can copy paste. This you can copy paste, and the second argument is this namespace index, which happens to be 2. Okay, and right now we know where our register 04 is. So register 04 is at OPC-UA server, identified by this endpoint, and within the server identified by this address given by UA node ID. Okay. So the next part is write 05 into this register. So if you look at write value and read value, you can take this from header file, or you can watch the diagram. Let's maybe take this information from the diagram, might be more interesting. Diagram PDF, right? So I2C slave, and you see that value is UA byte string. So byte string is a type that holds a string of bytes. Is essentially a possibly very long array of bytes which you can send safely over OPC-UA protocol. Well, so what we want here is we want to have this byte string, right? Let's call it this way. And we want to have some sort of data, yeah, or 1 byte, maybe let's call it this way. And if we go back to the procedure says write 05, so I'm gonna assign 05 to this, right? Then I say that this byte string should have, should have a copy of this byte, so size of 1 byte, and then this is a pointer to this byte, correct? Yeah. And then what I can do is then I can just do write value. Okay, it's in here. So what I can do is register 4, write value, okay, yes. Then there's another argument here. Look, and that comes from the concept of UAO. So the first one is the data you want to write. The second one is the status, which is kind of like output status. So it's gonna by default is null, right? If you keep it null, what happens is if this call fails, and the same rule applies to all other write read calls, right, in UAO. If this call fails for some reason, and you supply, you initialize output status to something that is not null, then you're gonna, there's not gonna be an exception, and you're gonna get into output status the result of the operation. If, however, you keep it null, then you're gonna have an exception thrown, right? So it's, I think, very convenient because you don't really have to check it afterwards. So I'm not putting this argument, yeah? I'm just saying write value in the data, and that should just throw an exception in case something is wrong, right? So what I will do here, okay, so imagine this was actually fine. What I clearly want to do here is I want to delete this session. Okay, it's gonna disconnect and everything. And since this might throw an exception, then what I will do is the following. I put this into try catch block. Yeah, I'm gonna catch like any standard exception that might come from this thing. In case it comes, what I'll do is I'm gonna log it. I don't know, something like this, for instance. Yeah, and then I'm gonna return OPC-UA bad, for instance. In other case, I will assume everything went fine, and I will return OPC-UA good. Now, this code is not perfect, but we'll try to give it a go, and we'll improve it in a small second. So, saved, and let's see what happens. So, LTDB build. I'm trying to build this project. Let's see. Okay, I'm actually surprised it's built because I'm just, kind of writing this on the go. So I'm running my OPC-UA server. Okay. And so this is my peripheral OPC-UA server. Configure. Let's call it, why not? Yeah. Succeeded. Okay. How can we see if it succeeded? Well, if you have the real hardware, then of course you can read from the real hardware. What I propose you when you have the simulator is the following. Whenever there is a transaction going to SCA in terms of whatever goes out of the OPC-UA SCA server towards SCA, like NetIO or towards Felix Core, then if you use SCA simulator, it's gonna print the things on the console. So I will do this again, and voila, I see some traffic towards SCA. Of course, with the simulator, I cannot say if that was correct or not correct or anything like this, but at least I see something, which means it probably worked. Just to be more convincing as a demo, now look what I'm gonna do. So I'm gonna imagine I don't have the SCA, so I'm killing my simulator, right? And so it kind of corresponds to a situation where there's nobody will really reply to this traffic from SCA. And now let's try to see what happens when I click call now and failed with bad. And then if you look at the server log file, it's telling you call to OPC-UA write failed, blah, blah, blah. One of results not good, but our service status code like it shows here. Okay, so I don't know if I managed to convince you, but at least you see that the basic test kind of passed, and that this code indeed connected to the primary server and did what it was requested to do. Okay, so what's our situation? So let's maybe commit all those changes. So then, if you see, if you look at configuration procedure like this one, and I think many of them will be similar, then essentially that will be like a sequence of operations. So essentially you are free to structure them as you like, and of course you don't really, if you for example, when you implement this in GPIO sequence, and there will be like a lot of things like like creating an object and doing this and writing. Of course you should write a method or function or whatever have you they're gonna automate this. Don't copy paste this code like 15 times, right? And this should be really manageable, done in a clever way and everything. And I think it does not really have to be set. And I'm pretty sure we find a good way of writing good code here. If not, you can ask us for some advice, because there's a lot of possible tricks which we can also advise to. Anyway, what is maybe less obvious, and I'd like to show it at this moment, is that look at that when we coded this configure, what happened here is we had to use some data which we kind of hard coded at the stage. So for example, the address, the endpoint, OPC-UA endpoint of the server which holds the connectivity, the primary SCA connectivity, as well as the address of those fields, right? And those things should not already be in the code. And so the question now is, how to make it the proper way. So in Quasar, there's a couple of mechanisms which you should use for this. So for example, we have to store this OPC-UA endpoint, right? And if we look at our current design diagram, no, this is wrong, sorry, right now. Let's see, this is the one from the primary server diagram. Okay, this is a very simple diagram which we have at this stage. So it's obvious this should not be in the code, so let's actually put this into the configuration file via Quasar. And now let's also wonder where this should go. The reference should it be a config entry per MTRX? Probably not, because it's gonna be the same per LTDB SCA, right? So probably we should put this in this class. And then the question is, well, maybe it should be on LTDB. I actually don't know. I suppose the most obvious point would be per LTDB, because I suppose that all connections towards SCA for a single LTB would be handled by the same SCA OPC-UA server. So I'm gonna put it essentially there, but that is again case by case information. So what I'm gonna do here is the following. I have the LTDB, okay, and what I will add here is the config entry, and the config entry will be of string type. Where can I find this? String type. And I'm gonna name it like how can I name it? Like SCA OPC-UA endpoint, for instance, like this, right? And I maybe gonna help myself a slightly bit by adding an attribute which is stored in device object, which means we're gonna always have a reference to this, which is helpful in future. Just believe me, it is. And let's see how this changed our diagram here. Okay, so now we have this config entry SCA OPC-UA endpoint. So a small hint here that if from device logic, if we want to access this information, what you either way probably will do, but what is helpful at this stage is actually to declare device logic for those remaining two classes. It will be just much more easy to access this information this way. So I'm adding device logic to this guy, and I'm adding device logic to this guy. And as you remember, right now I'll have to actually generate the initial version of this device logic, which would be for LTDB and LTDB SCA. And in order not to forget it, check consistency -- ask, I'm gonna commit those files into the repo and maybe rebuild Quasar. Sorry, rebuild the peripheral server. Okay, so the server is recompiled, and let's maybe see what it changed. So we we added this config entry, right? And now what it means is that that the config file right now should be supplied with this information. So if you open config file, you reload the dependencies, and now let me see if I do add attribute, you see? So the schema for the config file for running the server now actually requires that you put this information like SCA OPC-UA endpoint, okay? So I'm essentially moving this information from being hard-coded into the config file. So I'm gonna take this out from here. Okay, I'm gonna put it here. And now the question, how do you access it from in the runtime? Well, here's what I'm gonna do. I'm gonna do connect, and we are at the stage, right? At this class, LTDB MTRX. So what I can do here is I can do get parent, yeah, which is pointing me to this class. I can do get parent again. And if I say SCA OPC-UA end, sorry for this. If I say SCA OPC-UA endpoint, this essentially should be what I'm looking for. You know, it's gonna return me a standard string, you know, which is this information coming from the config file. Now, why it doesn't like it? Because it expects UA string, but conversion to UA string is, you know, I can just do C string like it was a C string. And you know, and now this becomes part of the config file. So now since I think I rebuilt it. Oh no, of course not. I had to compile this. Now let's try to run it again. Now let's see if it actually works. Okay, so it looks like working. And now let's test it. So I'm running call here, and indeed I saw the same transaction. So which means now the information is moved from the source code into the config file, which is exactly where it should be. Okay. So exactly the same thing should happen to this one, right? But why I don't want to do this, I don't want to guide you with this one is, well, two reasons. First of all, I don't really understand, because this is very case specific, you know, if this mapping is kind of so loose, or if there's something algorithmic, you know, in the way it can be generated. So I trust that you, since you know your hardware, I trust that you know how to, you know, manage this mapping. Maybe it doesn't have to be explicitly coded in the XML. Maybe that could be a for loop, or, you know, whatever. In case it has to be explicitly coded, you can use exactly the same approach that I shown you with this thing, so you will probably manage with that. Okay. What we have covered is writing values. The same goes for reading values. So in case, I actually don't know if this is your case, but in case you wanted in this or similar procedure to actually read something to check, you know, if it was correct, write a note, or just make some supervising algorithm, this you can of course do, and you can of course, you know, the write, read, compare, or whatever you find is relevant for your hardware, and then maybe, you know, return OPC-UA bad if the configuration was wrong, you know, or something like this. Feel free to ask questions to us, and we'll try to answer all of them. And so I'll not be going much more into the details how to write this code. It should be pretty much obvious to you at this stage. Now, what might be interesting though is you perhaps remember this picture. This picture here when I drawn like the hardware decomposition, right? So there's like MTRX and the GPIO IO and something. What I'd like to maybe show you as one of the last steps is that you can have multiple, you know, has objects, and this procedure assumes that you do something on MTRX, then you do something on GPIO, and then you do something on, you know, MTX, or I don't really know what that is, so I'm sorry for my ignorance. But let's assume now we add this. You know, I'm not gonna write code, but it's just for modeling. It's just for modeling in here. So what I'm gonna do in Eclipse is the following. I'm gonna add another class. I'm gonna do add another class which is LTB-GPIO, and I'm saying from inside this class, I'm saying I'm adding second has object. I'm saying it has LTDB-GPIO, right? And then if we look how it looks from the perspective of the diagram, this is what happens. So we have LTDB-GPIO where I'll again put I add the configure method. So I added this method configure on LTB-GPIO, and here's what I'm doing here, and why I'm doing this is the following. I want to show you when you change the design on a class which already has some device logic, right? So that would be LTDB-SCA. So I'm just showing you that what happens, and what you might you know, come across is you're gonna need to just trust the merge tool. Okay, in here, and LTDB-GPIO, I suppose. Okay, let's see if it builds. Okay, so after having built this, it's how it looks like, and what I want to say is that you don't really have to, or it's not maybe the best way to put configure or to use configure for all individual objects which you're gonna have here, because you can have many of them. I still think you should have this, but what you can do both for good engineering practice as well as for usability is actually you can have one master configure which gonna, you know, go through the different objects which you have, and you would call, you know, the different configure, and that's what we're gonna try to do at this stage. So I added configure into empty array. Well, this we added actually, you know, beforehand. I just added the configure for LTDB-GPIO, and I'll add also configure method to LTDB-SCA. So where is this thing? So it's here, I think. Add child method. It's configure, and what I'll try to do here is whenever I seem to have some pretty intensive I/O in the background. Whenever somebody calls this configure, which I just added to LTDB-SCA, I will, you know, just make an equivalent of sequentially calling different configure in here, right? So let's do that. So I just added that configure. I have to, I suppose, generate device for LTDB-SCA because I added a new method, right? Yes, this is the new method which I have here. So that was the header file and the body here. And look, here's what I will do. So I go to the new file, which is device source refresh. Why I don't see this? Oh, here it comes. No, it doesn't. What happened here? Right, I was looking in build device instead of device. So if I now look into this, no, cancel. What the hell? You know, I'm recording a screen here, and there's quite loading my machine. That's why this strange thing's happening. Okay, anyway, so I have here this configure at the level of LTDB-SCA, right? At this level. And what I want to do now is that I actually, from this guy, actually called all the configure both on MTRX and or GPIO. So that would be like complete configuration per given SCA on LTDB. So what I can do here is I can do the following, or at least I suppose I'll be able to do that. So let's iterate. So for all LTDB MTRX, which are in the collection of LTDB and MTRX, I suppose. Yeah, we can find this, right? I want to do the following. So UA status is MTRX configure. That should be correct, right? It's just Eclipse not really finding the mapping, I suppose. Well, we can try to build this and we will quickly see if this is really correct or not. Right, so I think it was not really configure, it was obviously call configure. Here I was slightly wrong, sorry for that. So, so I'm iterating through all MTRX here, and if not status is good, so it was anything different than good, then I'm gonna just return the status which was not good, right? And the same thing I'm gonna do for LTDB GPIO, right? So the LTDB GPIO, right? GPIO LTDB GPIOs. I'm gonna do GPIO call configure. Did I do something wrong here? We'll see in a second. And if not as is good, we return as. Okay, let's try to build it. Okay, so it was just Eclipse, which apparently I didn't configure properly. Looks like everything compiled here, so now we can actually try to, I think we can try to run it. And now let's see whether when I run configure on LTDB SCA, which by the way I think I should regenerate this diagram just for a good picture. Yeah, now you see we have configure on LTDB SCA. So now let's see if that's gonna trigger configuration on LTDB MTRX. So that comes from the previous thing. Let's maybe rebrowse this. So now you see we have SCA. It has its own configure right now. Okay, it's gonna run it. Okay, it says but not implemented because probably it was my fault here. At least I expect. Yes, it was apparently my problem here. So I'm gonna fix this right now. Quasar build. Okay, let's run it again and let's see. So, okay, it's running. So in the simulator, I'm just gonna clear the screen just to see the transactions whenever they appear. And now I'm running this thing, and it says succeeded. And indeed, I see the transaction, which essentially means, you can also add configure or whatever you want onto this LTDB level, and it it can do recursive configuration. So I was trying this to kind of give you the information that you you should have this this DCS integration aspect in mind, and of course it's if you can do nicely the same thing from one call, then why would you force the user to do thousands of independent things? I mean, this is much more elegant than running all of these separate things, while still the separate things can be individually called if there's such need. So it's probably just simply better. Okay, so that mostly concludes what I wanted to say in the second part of this training. There's much more different aspects which could be covered here related to how Quasar does this or does that. And what one should say is, apart from methods here, you could also have variables, and maybe there's something that you want to keep running in the background, something that keeps monitoring, I don't know, the voltage or something on the ADC of Nevis, or I don't really know, because I don't know your hardware. I just want to say that it's entirely possible, and this is the way in which you should do this. So my proposal for you at this stage is that you follow those steps, and if we just get back to us, and if we identify what are the additional requirements from you, then we simply see how to put this into this framework, how to do something that would be applicable to DCS integration, or that would work well in the context of DCS integration. So that was the end of part 2. And we're waiting your feedback, and then we see what goes into part 3, if there is anything that goes into part 3.